In Chapter 1, we looked at ways that statistics can be misused in the form of misleading graphs or things like taking a categorical variable, such as a zip code, and then trying to average a list of zip codes. That just doesn't make a lot of sense. So in Chapter 2, we're going to continue this idea. We'll look at another way that statistics can be misused. So these examples, the statistic, the min, the max, the average, are all calculated mathematically correctly, but what they're being used to represent doesn't quite match up. So let's look at an example of this. Our first example is a warehouse style store like Costco. So they have two membership tiers there, a basic level and an executive. And the executive costs more, but it comes with certain perks. Okay, the store wants to determine who their best cashier is. And one way of doing that that's been proposed is to see who gets the most upgrades, with the idea being that the more upgrades you get, the better you are at cashiering. So that sounds like not a terrible idea until you kind of think about the specifics that go into it. So you're only able to get an upgrade if you're actually cashiering. So if the store is short-staffed and they need you to go do carts or to stock shelves, you're not on the register, which means you don't have the possibility of getting an upgrade. So that could decrease the number of upgrades that you get. The time that you work, or even the day that you work, can make a big difference. So if you work at 5 o'clock when the grocery store is really busy, there's lots of people coming through your line, more opportunities for people that need upgrades. Versus if you work early mornings or late at night, the store is usually really quiet, so you're less likely to get an upgrade. So just because someone has the most upgrades doesn't actually mean they were the best at being able to get them. So maybe a better way might be the number of people that the system flags for potentially benefiting from an upgrade. How many of those was each cashier able to actually get the upgrade for? And that percentage might be a better way of determining the best. Okay, our next example actually comes from a TV show. So this is from Chicago Fire. And there was a discussion on an episode about who is the best qualified to be the new fire commissioner. And the mayor doesn't want to be accused of just giving the job to his friend. So he wants to see some analytics, which means some statistics, in order to make an informed decision. So the mayor comes out and he says, well, Grissom's district has the best statistics in all of the CFD. They have more calls, they have more saves, everything. Okay, and I heard that and I went, well, that doesn't mean that Grissom is the most qualified for the job. So let's break this down a little bit. The first one is the more calls part. That means more people are calling in with problems. And I don't really know how the fire department could change the number of callers. So just because you have more people calling in needing help doesn't mean that you're actually better at serving the people or taking care of them. So it's kind of a weird statistic to have. Some areas just have more calls. That's just the nature of things. The more saves, so that sounds a little bit better. But then there's some issues there. So if you're getting more calls in your district, there's more potential to save people. So it would make sense that you have more saves. Another issue might be that you're in an area that has a lot of really severe accidents. So there's a stretch of road where I grew up that's one lane each way. They're not able to expand the road for environmental reasons. And when I was maybe 10 or so, they actually ended up turning the road into a triple fine zone if you speed, which I was like, wow, that's a lot of money. And my parents explained to me that the reason they did that is the first responders didn't want to go out there. They were going out to these really horribly horrific head-on collisions because one lane each way, so these cars are running into each other. By the time they get out there, the person is unlikely to still be alive, and so it's very traumatizing for the first responders. And so if you're in a district like that, the nature of the accidents in that district make it less likely that you're going to save as many people. And that doesn't have to do with the skills of the firefighters. That has to do with things outside their control. So I don't know that that more saves is really quite the right way you want to go about it either, although it is better than the more calls. So some other things that could be going on, you could have more newbies, so people that are new to the profession in your district. Maybe you're at a house that is short-staffed, so they don't have as many firefighters as they should. Maybe they have older equipment that is not in the best repair. There's a lot of factors that go into that. And just looking at more calls and more saves doesn't mean that that's the most qualified person for the job. So we can correctly calculate statistics, but they don't always represent what we're trying to use them for. Okay, and that's definitely something to kind of think about. How does that statistic actually relate to that qualification?